Howdy everybody. It is time to dig into this little project. We have got all kinds of fun and adventures awaiting us here. So this is the transmission housing to a pretty good sized Volvo loader. I cannot remember what model it is, if I ever knew it. I think this is about an 8-yard machine, if I'm not mistaken, but at any rate, I could be messed up on that. But either way, doesn't matter. Transmission housing, and it has spun out a bearing in this bore. These bearings are like a really light tap fit or a press fit in here because they get adjusted with shims and covers, and so they can't be very tight because as you're adjusting it and shimming it, you got to be able to move that inner bearing around that bearing race around pretty easy. So at any rate, this one, it must have picked up a junk. You know, the bearing spun in the house. It must have picked up a piece of junk between a roller and just spun in there. It's got a heck of a step bore in here. So what I got to do is get this thing mounted up on the horizontal boring mill. I'm going to have to put it, this is the bottom, that's top, and I'm going to have to flip this way because it has a machined face all on the backside here. So I need to get that mounted up onto a angle plate, and then thankfully, there's an unworn section here about the top 3/8 of an inch of it, so I can get in there with a coaxial indicator, get centered up on the bore, and then it's going to be time to punch it out. I'm going to go into within, I don't know, I got to do a little bit of measuring and decide this, but probably we'll drop in there to within, say, 150 thousandths or so of the bottom of the bore, and leave a shoulder in there is the plan, so that I can shrink sleeve in. Now what I wanted to do is I wanted to use liquid nitrogen, make a sleeve, freeze it, drop it in there, but there were no doors available at all. So we are stuck with just what I can accomplish with heating this and sticking the sleeve itself in the freezer, which is not near as good as liquid nitrogen. So pretty bummed about that. I didn't do the math on it yet, but I would think one this size, I could probably shrink that thing 5 thousandths with liquid nitrogen. As it is, I may still go for that. To be honest with you, I'm thinking it over. This, what is this diameter? Let's do a little ciphering. So we're just shy of 5 inches. I can probably get away, yeah, I can do 5. Because what I can do is I can pull it in. What I'll end up doing is I want to install the sleeve on the boring mill. I really prefer to do that, because then I can leave it all centered up on it and go in and finish cutting it after the sleeve's installed. I have done jobs where I had to calculate the crush, but it's just not as exact of a science as you'd like to believe it is. So my preference is to machine the sleeve, leave the ID undersize, install it on the boring mill without ever re-zeroing anything, and then go right in there and finish bore it. And I can do that by dropping a threaded rod through here with my porta-power and just pressing the sleeve in. We'll do that right on the boring mill. So at any rate, that's what we're getting ready to do. So I'm going to start getting set up. I think I'll probably just shoot a time lapse of getting this thing on the boring mill and getting it set up, and you guys can watch the chaos and mayhem ensue. Here's as close as we can get it. hole's got a little bit of outer rounding to it. So we're gonna lock down all my X and Y axis. Zeroed out my digital readout. It is time to set up to do some boring. Guess I gotta decide how deep I want to go before I get started here. It's a 2-inch deep bore. So I'm gonna go in inch 800 from the face. Yeah, we're barely going to leave a shoulder in there because when it wallowed around in there, it was rolling off this back edge. So I was starting to get worried, but we've got a shoulder. Shoulder's a shoulder. It can't escape into there past it, so we're going to roll with it. But that's definitely about all we could get away with. What I got to decide now is if I'm good with 100 thou. Really I'd like to see about, I think we're going to take another 25. I'd like to see an 1/8 inch on a side. That's 125 thousandths on a side. Should be plenty of sleeve thickness. So we're going to go ahead and bump this tool out another 25 thousandths and then take a pass. Let it cut back out now. I just reversed the feed. Basically let it do a spring pass on the cutout. I'm not really trying to hit in a particular number because I'm going to machine a sleeve to whatever it is. It's a lot easier to hit a particular number in the lathe than it is here. So just cutting it out. In theory, that hole is exactly a 1/4 inch oversized compared to this one. But in practice, I could be off by as much as 5 or 10 thousandths with, you know, just hauling up and cutting it after touching off on the face. But we don't care for what we're doing now. Well, there she be. I can taste the iron in my mouth just from the dust it put in the air. Absolutely beautiful. Alright, I'm going to go grab a pair of calipers and just for grin see where we're at here. So, first question is, what is a factory bore? I'm sure it's some metric number, but 4.720. Yep, I'm exactly 5 thousandths over my attempted 1/8 inch on the side, so I'm frankly just tickled with that. So the deal here is, I've got her, you know, I've got my locks table and column lock set. I've got this zeroed. I'm gonna leave all this sitting right here, and I'm gonna go get set up in the lathe over here now. and cut a sleeve to go in there. Leave the ID undersize. I'll cut a chamfer on it on the lead-in edge, and probably leave the inside undersized by, I don't know, good 10 on a side anyways, with the idea then that I'll come in here and finish cut that after I press it in. So let's get on with that part of the project and leave this sit until we get it done. So our goal here is 4.980. And we are just barely cleaning up at 4.985 right now. So what we're going to do is we're actually going to come up and take a spring pass here before I do anything. This is really wanting to sing. I've been fighting it. I had to really turn speed down and playing with it. You can hear it kind of just trying to take off in the background there. It wasn't quite as bad when I was taking more of a cut. I'm honestly tempted to try a bit more press fit. One of them diaphiles, or what do they call them, tube dressing sanders, but I haven't been able to convince myself to cough up the money yet. Too busy buying stuff like 1937 Fords, you know, important things. I don't know if you guys can see it, but see all them gritties in that back way? Back her up, away from the gritties. Shifted on me on one of my last passes because of a chip wadding up under there, so I had to true it back up. Now I'm taking a skim cut to get squared back up. Thankfully this is not critical in here. Take another 40 and then call it. We'll say another 30. Don't want to get too greedy here. As far as I'll go then, once it's pressed into place in that transmission housing, then I'll go back in there and finish boring it. See them chips wadding up under there is what throws it off center on me. If a big enough one of them gets in there and jams in there, it exerts a lot of pressure on the part. It's part of why I don't want to go too close to my final bore dimensions. Right now I'm far enough from it that I can handle it throwing off center a little. It wouldn't be the end of the world. All of this is because I'm too much of a material miser to cut that piece off so I can grab it closer. Alright, now what we gotta do is blend a chamfer in here. Just now starting to get down to the actual depth where that chamfer will still exist. Alright, so by doing that, once I put this thing in the bore, press it in, this facing out, and finish bore it, then that chamfer, some of that will still be left behind, because you can see, I'll show you, the factory bores have got a pretty good chamfer on them to help start the bearings in. So I want to add that back in. So I'm going to do some polishing on that, deburr it, and then we're going to cut this off in the bandsaw, spin it around, and face the other end now. Alright, so I put a light coat of oil in there. I'm going to see if I can get it started here. I don't actually expect to be able to get it all the way in. I had this in the freezer. All right, now going in very nicely. Now the one thing you gotta watch out with this is you frequently will knock bits of junk off. It'll end up sitting down there in the bottom and messing with you. But she's going. One or two more good swats to make all the way in tight against that shoulder in the bottom. Feels pretty dumb good. So that was 1.5 thou per inch of press fit that I just drove in. Especially on thin bushings that are just made out of this 4140, it's not hardened. They'll crush a lot on installation. So I think what we'll probably end up doing is coming out here and just touching that face now, because it's standing ever so slightly proud. So I think what we'll do is we'll just leave this tool where it's set, come up, touch that face off until I get rid of that, and then we'll reset to run the board a proper size. I think what I want to do is I actually want to bump the tool out just a bit so that I can tell, you know, right now I'm at the diameter that I ran the bore at, and I want to be able to tell when I reach the original surface. So I'm just going to go ahead, bump it past just a touch, and then I'll just come up until it kisses the face at the edge of the hole, and that'll be good enough. Yep, that's what we wanted to see. No step, perfectly blended in. All right. Time to back this tool off. We've got her pretty well maxed out on how far you dare extend this tool right now. The same thing that I did when I started the boring, which is to just come in here, take a pass through, yep, that's perfect. We'll let that cut through there, and then we'll get some dimensions and see where we're really at. Pretty spiffy. Well, let's get some idea where we're headed and where we're at here now. Put 724. Write that down. Yeah, I get a good, I'll say, gonna peel 30 out. We'll bump the tool up 15 on a side, and then take another pass through and see where we're at. Okay, look at that. Ain't that pretty? Machining like an absolute dream. Alright, I'm going to get in there and do some measuring again. We're taking 7 thou on a side here. Should be our final roughing pass, if you can call 7th thou roughing, and then we're going to see right where we're at. Normally I would not measure something like this with calipers, but the fact that I have an unmolested factory bore right there to compare it with, you know, I'm not trying to measure the bore, I'm just comparing it with the other one, and I trust the calipers for that. They're very repeatable. So if I was trying to hit a particular number based on a print, I'd have a dial bore gauge and a micrometer set up for this, but with what we're doing, we're just trying to exactly replicate what the factory thought was a proper fit in this bore. So anyway, looking pretty good though. We've got 5 to go. I decided to take a spring pass through there, even though the last cut was really light, just to make sure. And it's interesting, I literally cannot see in the bore where the cutter is currently cutting at, but little shavings are showing up in there, so it's clearly taking something out of the bore. So I'm going to let it pass all the way through there that way. Then we'll get a measurement and take our final adjustment and pass final cut then. So too much monkeying around to risk overblowing it because there was more spring going on than what I accounted for. For the extra 5 minutes it cost me to take this pass, it's well worth it. And you can see there's a fair amount of little shavings piling up in the bottom of there, so it's cutting something. Alright everybody, so I've got it bored. It overshot, or I say it, I overshot my dimension by about 0.5 thousandths, which probably isn't make or break. This one, that 0.5 thou is the difference between this one needing to be tapped and this one. If you get it just right, you can get it to slip in there. There it goes. But there's something else I'm not liking, and that is it feels grabby. I don't know how to describe it other than to say that's a piece of hydraulic cylinder tube that I made that out of. Most likely 4140. And I'm concerned, I have had issues. This is just coming to me as I'm thinking it over, because this has to be a really light tap or press fit, which means there's a decent chance that under load this thing is going to shift in here over time. And as I've thought this over, I'm concerned now that I'm mulling it over that this and that sleeve I put in there might get in a fight with each other and decide to gall up if it does that. So I went digging around, and I have got a chunk of cast iron here. And as crazy as this might sound, I think I'm going to turn a new sleeve up. Just see how it looks once. If I'm happy with how that's looking, I'm going to go back in here and I'm going to cut this first sleeve that I made back out of here, and we're going to put an iron one in. I don't know how to put it. I've got a bad spidey sense about this. I got two things. First off, it should be a slightly snugger fit than what it is. I'd really like it to be a tap fit in there. Part of what's fighting me here is this bore's got a lot of dents and boogers in it, and it's hard to decide how much of what I'm feeling is me. I've been in there hand sanding, but anyway, it's hard to tell how much of the feel difference that I'm getting is caused by size, how much is caused by the fact that this is steel and that's iron. But at any rate, I just don't like it. I don't like it. We're going to put an iron one in there if I get one cut that I like the looks of. But we're going to leave it be for right now until I've got one I'm happy with, though. So that's what we're up to. So I'm on my final pass in here. I'm leaving 5 thousandths worth of that sleeve that I'll just crush and pull out of there. I'm hoping to avoid having to rebore the parent bore at all. You know, it's one of the funny deals where it's hard to describe. I do a lot of stuff just based on, I'll call it a spidey sense. Maybe I'm being crazy and overkilling, but I just had a bad feeling. It was when I slid it in there. If it would have tapped in, I might not even have thought anything of it. So I guess I'm indirectly glad that it was a little looser than I wanted, because it gave me a chance to feel it. And basically those two materials, the bearing race and that bore, I think from the way it felt, we're not going to be friends with each other long term. And then if it spun in there at all, I was going to fully expect that thing to ball up and lock itself in that bore. So at any rate, we're going to knock it out. I got some really nice continuous cast ductile, or I don't know if it's ductile, but continuous cast iron over here we're going to put to work next. Well, before I got finished cutting, it started spinning in the bore on me, so hopefully I can get this booger to come out and it hasn't done anything ugly to my bore by doing that trick. I'm a little concerned that I've got a bit too much to just get to come out of here nicely down at the bottom yet, so 5,000 shim stack, anyone? I really like a way to get behind that and hook it out of there. I think I'm going to run this down further so I'm away from the tool here. Alright, I remembered I've got this homemade slide hammer that part of it is something I got in a collection and then I made this for it. I was using this yanking seals. I'm hoping that if I'm gentle with it, it's got enough oompah to hook in here. Oh, that's what the doctor ordered right there. Why you keep lots of junk around, guys. You never know which piece of junk is going to be the thing that saves the day. Now that I've got it moving a bit, it does seem like I'm able to give a little yank here and there. There we go. Alright, let's take a look in here. So it had, see if I can find a spot. Right here, my tool had jammed up in it when it spun and broke the tip of the tool. So that cut one little groove around in here, but for what we're doing, that will not matter. We're going to have a nice heavy sleeve in here, so I think I'm okay with saying we're just going to go ahead and machine another sleeve and slap it back in there. I am curious if as it was trying to feed in, it took me a couple seconds, if it has worn that shoulder in any deeper, but I think I'm going to deal with that by just intentionally leaving this sleeve a little bit proud and then facing it off to the depth, so. At any rate, I think we got a winner, guys. Let's get on to making the new sleeve. Alright, it just was not stable enough hanging out that far. It occurred to me that for what I'm doing, I could just cut a piece a little over 2 inches, cut it, flip it, cut it. So now we can take some real material off. Shattering and shearing up. It's just good quality gray iron. Look at this. Alright, where did that put me? Under 6. So now we start measuring for this. Ready for 5. We've got 700 pounds total. Check this in. Take another 400. you see, I've left this iron sleeve a lot heavier walled than I did on the original, or the steel one that I made. And that is because I anticipate more of a fight installing. In fact, that's feeling a little... I left it with a bit more press fit on it than the last one. Feeling a little bit uninclined to going in, should we say. I may have to go ahead and shave this thing down a little bit more. I might have got too ambitious with the amount of press fit that I thought I'd get. I'm going to go do a little measuring. We'll see. I may have to skim a little more off this thing. Alright, I put a nice polish on that in the lathe. I didn't actually machine any more off. I just put it in there and gave her a good polish and really worked at getting this leading edge. There. That. All right. Beautiful. So I've intentionally left this one a bit longer. After I was driving the last one in and I realized I was going to have to face it anyways, it occurred to me that when you're driving it, you might accidentally coin the edge over a bit. And it'd be better to cut that off than risk it stopping me from getting all the way to the bottom. So anyway, we're going to fire this head up with this 40 mil up and we'll cut back through there and get this thing finished. Alright, we're on what is probably our finished pass. I cut in there about ½ an inch, backed out and measured it, and it's still a little on the tight side. Probably gonna just hone to finish fit. I'm paranoid of overshooting. Say I'm not getting. You can feel a little bit of catchiness in the surface in there when I feel it. So I think I want to at least hand sandpaper it once after this pass and just see, because sometimes that little bit of roughness in the surface is enough to fib a little bit to you on your final dimensions. We'll get cut through there, get some measurements done, see how the bearing itself fits compared to the bore or feels, and then go from there. So, we're going to try something here. I grabbed this boring attachment and just hand sharpened myself a piece of high-speed tool steel to an approximation of that chamfer. We're going to see here if I can get away with just zinging my way in here. I'm going to put the camera down a minute. See what happens. Really like that chamfer. Factory put one in, so I'd like one. This is where the ductile iron is really helping. If I was trying this with a piece of steel, there'd be the devil to pay already. Alright. Well, I'm not gonna lie, I'm pretty proud of that chamfer. Look at that, would ya? The bearing actually sits down in here beyond it, so the depth of the chamfer isn't critical. Its real purpose is just to help you get the bearing started. So anyway, Well, everybody, I think the time has come to drive this thing down to the other end and prepare to unload it, but we're gonna call her a night. We've got a done, finished part. They can come get her in the morning, so there you have it. You know, I hesitate at times to show like the flub ups or the missed steps, but I don't want people to get a misimpression of like, you know, I don't know everything I'm doing when I start. Like this 4140, which I'm assuming that stuff was. I mean, it's a cylinder barrel off a hydraulic, so it's probably seamless drawn 4140. Seemed like a fantastic idea, but got in there, and as I was feeling that fit, I was having some flashbacks to times that I had actually in my boring setup used boring bars made out of 4140 with bearings running them. I had such holy fits with them galling up and locking up on them. So anyway, and then as I was thinking about that, I remembered this piece of continuous cast ductile iron. Honestly, I didn't remember that I had that when I first started this project. So, you know, and this is all one of those just figure it out as you go sort of things. So just to give you kind of a frame of reference though, so then the other thing I struggle with is like, okay, do I charge the customer for all the time, just the time I spent on this? And here's where I'm at on this one. This job, I haven't sat down and figured it out, but if I include all of the time right now, and I'm probably gonna hit them, you know, 50 bucks or better for that piece of ductile iron, just because I'm keeping that stuff on hand. We're here on a weekend. If I don't keep that kind of stuff around, they aren't getting projects done. So I do upcharge a bit on material for that kind of stuff. But then including that, I'm probably gonna be 800 bucks if I charge them for everything, including making that part. I originally told them I could get it done without exceeding $1,500. So on this one, I'm here on a Sunday night till 8 o'clock getting it done. We're gonna bill them for all the hours, including the dead end that proved to be. You know, that's probably $200 worth of the whole project, or maybe even less. I won't charge them for the material, but at any rate, I think that's fair. Like I say, I come in on a weekend to get her punched out. They get their job done for about 800 or so bucks. I'll figure it out. It might be a little more, it might be 900, but substantially less than I told them it would cost, and I think everybody's happy with that. So anyway, you guys all have a good coming week here, and we'll catch you later.